All right, we are still in 1.2 talking about functions and many of the different characteristics. One of the characteristics of a function that you are going to be asked about is continuity. Continuity, or if a function is continuous, means that the graph doesn't come apart at a particular point. So you'll hear a couple of different things. One thing is a point continuous? So a particular value for x, if you look at that value, is it continuous at that value? So in other words, does it come apart at that point? You're also going to hear about, is a function overall continuous? And a function is continuous if each point is continuous. So we're going to focus probably more on the points, but just one informal way to know if something is continuous is, can I draw this entire graph without lifting up my pen? If that's the case, then we're talking about that function overall is continuous. Now, on the flip side, let's talk about discontinuity. What does it look like to have a function or a point that is discontinuous? We're going to do that by looking at several points of discontinuity, specific ways that a function can be discontinuous. First one is called a removable discontinuity. A removable discontinuity is one that has just a hole, and it can be filled with a single point. So if it's removable, we're talking about a single point of discontinuity. Here are a couple examples that I took from the book. Notice that there's a hole right here on this one, and a hole right here. The only difference between these two is that the point is on this one is moved up somewhere else. Here we threw the point away. That doesn't matter a ton for discontinuity, continuity, that kind of thing. But this is a removable discontinuity because it is just a single point. Another type of discontinuity, another point of discontinuity, is called a jump discontinuity. This is more than just a hole. It can't be filled with a single point, so it's considered not removable. But you'll notice here that we do have a hole, and then it goes right up here. It's basically like I cut this thing apart and moved the top one up a little ways. If that's the case, you can imagine the name makes sense because you go to here and then you jump to this one. That is called a jump discontinuity, and that is not removable. The third type of discontinuity is called an infinite discontinuity, and this comes up most of the time when we have an asymptote, when we have rational functions with functions that involve fractions. And so there's this vertical asymptote here. This is an infinite discontinuity because there aren't any points to grab onto. I say no anchor because it's like you really don't have a point that you can see. However, there is an x value at which this exists. And so an infinite discontinuity will look like this. It'll be going off in two different directions, or it's possible that we could be going in the same direction, but we're looking for some, infinite behavior one way or another when it's an infinite discontinuity.